All right, we've talked about a lot of different security things. Now we're going to kind of pull from all over the place and talk about a couple of things we haven't really talked about related to security, related to encryption, and secure web browsing. So the first thing that we're going to talk about is what's called the DiffieHellman Key Exchange. And this one is important because I've implied in past videos, that secure web browsing through HTTPS uses asymmetric encryption. And that's only partly true. Asymmetric encryption with public and private keys and certificates and all of that is used to authenticate who you're talking to. Specifically, your browser authenticates the server that it's talking to using those public keys. To actually do the communication, though, you're doing something a little bit different using symmetric encryption. And the DiffieHellman Key Exchange is the way that we can decide on a symmetric encryption key without having any secure way to talk before, because we have to have the same security or the same symmetric encryption key in order for me to encrypt a message and you to be able to decrypt the message. But to do that, we have to share the key. And this illustration on the side with paint, take a minute, look at it, kind of figure out how it goes. What it really comes down to is a way for two people, Alice and Bob, or two entities, your browser and the server, for example, to share information and come to a identical symmetric encryption key without having a secure method to communicate before having the symmetric encryption key. It's pretty awesome. And it allows us to use symmetric encryption, which is much faster than asymmetric encryption in the web, which provides other benefits, including the next thing we're talking about, forward secrecy. Now, with symmetric encryption specifically, but also asymmetric encryption, if at any time a key is compromised, all messages encrypted with that key are similarly compromised. And what that means is anytime I get compromised, we're hosed, and any communication we had in the past is compromised, any communication we have in the future is compromised, and forever that communication is compromised, and that's bad. That's really, really bad. This is especially true, again, with symmetric encryption, because we have that shared key. All of our messages use the same key. So the solution to that, then, what enables what's called forward secrecy, is to use a short-term symmetric key for each session, or even potentially each message, if that's the way that the communication is happening. And these short-term keys are only used for a limited amount of time, meaning if I compromise a key, or if someone else compromises a key, all they get is that tiny little snippet of conversation, that tiny little bit of communication between me and whoever it is that I'm communicating with, which allows our future and our messages before that session to remain secure, and basically forcing them to crack the key for each of those sessions individually rather than cracking one key and having access to all of them. And that's pretty awesome. And that similar principle using short-term keys allows our next topic, deniability. And deniability is especially important for someone like Edward Snowden. Edward Snowden wants to be able to communicate with journalists and verify that he is Edward Snowden. And journalists want to be able to verify when they're communicating with him that they are in fact communicating with him, and that the messages that they receive are coming from him, and so that they're reliable and things like that, right? But Edward Snowden has another important problem, and it's that he doesn't want what he says to be used against him in court, or to potentially be used against him in court. And so the way that you can implement that is using those same kind of short-term keys, but including them with every message. So you authenticate just the same way we do with a web browser. I authenticate that I am talking to Edward Snowden, or that I am talking to Google, using those public keys. And once we've authenticated, we share that symmetric key that we'll use for the session to communicate. And for the short term, I know that that came from Edward Snowden. And so I can communicate with him securely, and I know that our messages are encrypted, and he knows that he's sending those messages encrypted to me. And because of that short-term nature of the session, we can be fairly certain that the session's not going to be compromised while we're communicating. So while we're communicating, we know that I am talking to Edward Snowden, he is talking to me, etc. But when we do that and we send the keys with every message sent, which means that I, the reporter, could, if I wanted to, fabricate messages to look like they came from Edward Snowden. And I could fabricate those messages to say anything that I wanted them to say. As a reporter, I'm not going to do that when I'm talking to him or when I'm reporting on the story because, well, ideally, a reporter wants to report the truth, right? And making up facts. Anybody could say that Edward Snowden said that anything, but having that authenticated communication is important. But that provides deniability in the future. In the case of, say, a court case against Edward Snowden, they can't use that communication with a reporter because of that deniability. Basically, the reporter could have fabricated every one of those messages, and there's no way to prove cryptographically that the reporter did not fabricate messages that they claimed were from Edward Snowden. So it implements deniability while still providing authentication for that communication. So it's pretty darn cool. Another random security thing that we're going to talk about, steganography. Steganography is hiding things in other things. And there's a whole bunch of different ways to do it. But within the image on the left, there is no secret message. Within the image on the right, there's a secret message that says, I think it says, this is the secret message. Now, you won't be able to get that because PowerPoint mangles the images and things like that. But you can easily hide, and if you look at them, you can't see a difference between the message on the left and the message on the right. And you can easily hide files, audio files, even other images. You can hide images inside of other images using what's called steganography. And there's a whole bunch of different ways to do it. And you can hide images inside of images. You can hide images inside of audio files. You can hide audio files inside of images. You can hide audio files inside of audio files. And it's just because of the way audio is encoded, there happens to be a little bit of extra space in those files that we can fill up with other bits without messing with the original file and without really changing the user experience. In this case, you can look at these two images and see that they're exactly the same, but one of them contains a secret message that you can't see. So if you're interested, you can go to these websites. The input site allows you to input a message and hide it inside of an image, and the decode input allows you to decode a message from a steganography, from your own image. So you can send secret messages that way. Terrorists love this stuff. You get an image, you get a board, a message board where you can post these images with secret messages that people aren't looking for, but the right people, the people you're trying to communicate with, are looking for, and they can pull those out. And if it's an encrypted message, then they can pull that out securely, review the message, and get what they want. I'm sure spies use it. I'm sure it's used for all sorts of reasons. So the last miscellaneous security thing that we'll talk about is secure browsing. Now, any modern browser, Firefox has private browsing. Chrome has incognito, in private browsing for Internet Explorer, and I don't know what Edge calls it, and Safari's got its own thing. Every browser has private browsing now, and this is commonly used for all sorts of things. But really, all private browsing does is tell the browser not to store cookies. And that's basically it. So what that means is your logins to Gmail or Facebook or whatever are deleted when you close the browser, and your logins from your regular browser don't carry over into the incognito browser. So it's basically a completely separate instance or separate browser that you can use. The problem is it really doesn't provide any extra security. It does prevent things from being saved to your computer, and it does prevent those cookies. So I use it if I want to get on my wife's computer and log into my account. I use the incognito browser so that it doesn't mess with her cookies and mess with her Gmail and mess with her Facebook and all that stuff. So I can log in and do what I need to do. When I close the browser, it's gone. Or if I need a clean browser that looks like it's not me. Because, for example, Google's search results are customized and tailored based on what you've looked at in the past, and Google's got all sorts of information on that. If I want to look at what the browser looks like for someone who's not me, then I can pull up a private browser, incognito browser, and run a Google search and see what the top results are there for someone who's not me. Because when I search for me, or when I search for whatever, I'm going to get a different set of results than some random person on the internet. So that's one good thing to... There are good uses for an incognito browser, but security is not one of them, because they do not provide any extra security, and anybody on your network could still eavesdrop on basically anything that you're doing and listen in and see anything that you can see, including what websites you're visiting. They can't see what pages on the website you're visiting if it's an HTTPS website, but they can still see what websites you're visiting, what you're doing on the websites potentially, or how long you're visiting the websites. All of that information is still available, even though you're using a private browser, if they're listening on your network. If you really want security-focused web browsing and a completely secure, or mostly secure connection to the internet, then you want to use a special web browser and a special service called Tor. And this is completely security and anonymity-focused browsing. And what Tor does is it routes your traffic through a whole bunch of different hosts on the internet. And these are called nodes. And there's pass-through nodes that only pass... They basically receive encrypted traffic and then send it on to somewhere else. And they receive encrypted traffic and then they send it on to somewhere else. And then they receive encrypted traffic back and then they send it back the way it came. And it routes that traffic throughout the world to essentially anonymize it and hide it. So all somebody listening on your network could see is that you're communicating to Tor. They wouldn't see what sites you're visiting. They wouldn't see what URLs, what IP addresses, anything. All they would see is that you are sending encrypted data to Tor. All the Tor node that you're communicating with knows is that you're communicating to Tor. And really the only site that is able to gather any information is the exit node. So it routes your stuff into the network, bounces it around a little bit, and then it gets to an exit node that sends it out to your final destination. So if you wanted to go to Amazon, your traffic would go into Tor, bounce around to a couple places till it gets to an exit node that sends that request to Amazon. And then Amazon responds to the exit node, thinking the traffic is coming from the exit node without having any idea who you are. Now, I wouldn't be making purchases on Amazon through Tor. It seems kind of pointless because you're linking it back to your own address. But there are a lot of things on the internet that you may not want linked to your own address. Now, Tor was originally created by the U.S. Navy. And the original design and the intent of it is to allow people in oppressed or free speech limited nations to express themselves anonymously and securely without having that linked back to them. So that's a perfect, good, legitimate use of Tor. There are less legitimate uses of Tor as well. So an important distinction, the last thing we're talking about here, an important distinction is something between the deep web and the dark web. The deep web is essentially anything that can't be indexed by a search engine. And that includes the dark web. The dark web is a part of the deep web, but they're not the same thing. So the deep web might include your email inbox, because that's not getting indexed by a search engine, at least if you're not using a Gmail account. Your Dropbox folder, your bank account information, your Facebook page if you've got privacy stuff turned on. All of that is part of a deep web. And that's just because it's not on the surface. It's not on the surface of the web that everybody can visit and everybody can see, right? So that is the deep web. Anything that's not indexed by a search engine is a part of the deep web. Now, the dark web is different. It's a subset of that. It's not indexed by search engines, but there's a lot of bad stuff that goes on the internet. And websites like the Silk Road that sold drugs and assassinations and who knows what are all a part of the dark web. And a lot of the dark web is only accessible via Tor. And they use special URLs called .onion URLs because Tor stands for the onion router, so these .onion URLs are accessible only using the Tor browser. And so there's parts of that that are only accessible if you're using this secure network. And some of them only if you have specific hardware or software installed and running on your computer will allow you to access it. Otherwise, they'll cut you out because they don't want who knows what going on. But just to be clear, the deep web is not necessarily bad. The dark web is referring to a lot of bad stuff that goes on the internet. And that is our miscellaneous security stuff.